He's been doing iOS since 2013, and he's here to share how a small group of people dragged Swift onto Android. I think this makes you know that he's on our side, because Android doesn't deserve Swift, but we did it anyway. Please welcome Pierluigi.
Welcome, and I'll start with a question. So please, let me know if this situation has happened to you before. You were working on a feature with your team, and after you deliver the iOS build, shortly after your Android colleague delivers the Android version, and then the PM and QA come back with their feedback. And every single time, there's a bunch of notes for iOS and almost nothing for Android. I mean, and that's fine, right? We're aiming to craft the perfect product. But one day, the curiosity peaks, and you actually open up the Android build. And what you see is something like this. Right? Does that ring a bell? Right? No handled error states, no animations, no translucency, shadows are off. The list goes on, but no one seems to bat an eye. And this, to me personally, has happened in multiple teams in a lot of different companies. But why? Well, the reason is because the market treats Android like this, like a checkbox. A checkbox in some project management grid, nothing more. If it works, that's fine, ship it, on to the next thing. However, the very fact that it exists makes cross-platform solutions viable and are being forced upon us. And all of them come with some sort of compromise to the product we can potentially ship to our customers. But we should never compromise on excellence. Hi, I'm Pierluigi. You can follow more of my rants in my socials. And I work at the left bit. I'm the mobile lead at the left bit. So what is the left bit? We're a small software studio, just 10 people based in Barcelona, and we specialize in native software. We build apps that range from a minimalist weather app to an e-commerce and complex communication solutions for the medical sector. However, we've been experiencing some headwind. We've had countless meetings where, after presenting to a potential client budgets and timelines, they always come up with some sort of this line, right? And this is not only something that we're seeing when meeting clients, also when you look around in the industry. This is the wizard you get when trying to add Sentry to your iOS app. It's on the third row. But the same thing happens in Firebase. You even have to scroll to find iOS now. Like, how did this happen? How did we get here? Like, I'm older enough to remember when Objective-C won the TIOB index for Language of the Year on 2011 and 2012. We were rock stars back then. I'm old enough to remember when Facebook built the dream team to make Facebook Paper, which was awesome, by the way, only to toss it after a couple of years like yesterday's news. Hell, I'm old enough to remember when Apple cared this much about iPad app, a podcast app on the iPad. Like, try pitching this today to Tim Cook, right? You'll be laughed out of the room when he asks the ROI for that animation. So what does that mean? What is the underlying signal that I'm seeing? And that is that apps are no longer R&D. Apps have become infrastructure, and we use them to interact with the world around us, and this makes them ubiquitous. So, as demand for software has exploded, apps could no longer be handcrafted, and design and components have to be commoditized. This is actually, by the way, why iOS 7 was so forward-thinking, because it helped create this economy of scale that we all benefit now. Fast forward that to today, and you don't even get to pick your app icon's colors, right? And we all know what happens when something is perceived as a commodity. This old Bezos quote kicks in. Right? Once something is perceived to be a commodity, the margin starts dropping. And this is when the 4 horsemen of the apocalypse enter. Right? With the promise of one code base to rule both mobile platforms, the finance team is salivating over the cost reduction. Excellence be damned. So where does that leave our favorite language? Where does that leave Swift? Right? Now that cross-platform, or at least code portability, is table stakes, can Swift deliver it? So, Air Force One announced that Swift was going to be open source in WWDC 2015. That was 10 years ago. So let's see the report card on where can we use Swift outside of the Apple ecosystem. So Linux. Linux was an Apple effort because they really wanted Swift to be viable on the server side. This was a strategic goal for them. So they did most of the legwork. On other platforms like Windows, this was completely community-driven from the browser company. So you have Jira to thank for this. And Swift can also be used on Wasm today as an official targeted platform. But where does that leave the world's most used OS? Where does that leave Android? Right? Because on paper, this should be the easiest one to port to. Right? Swift was designed to build apps. And on Android, you build apps. So this has to be simpler than to use Swift to build servers or to build web pages, right? Well, the initial progress was slow to non-existent the first years. And of course, this was community-driven, not Apple-led. And to this day, there is no official Android SDK. So this means that every time there's a new release, like yesterday's Swift 6.2 release, the community has to patch it around to make sure it compiles. But let's say that you were adventurous enough in 2015 or 2016 to try out Swift on Android. Technically, you could, but every time you hit what I used to call the foundation wall. And that is that it's impossible to create software for Apple platforms without importing Foundation somewhere, right? The Swift standard library only goes so far. And Foundation has been at the heart of all Apple software since they bought Next. So it's virtually impossible to write meaningful apps without it. And the fact that it doesn't have a logo, it breaks my heart. I had to use this. And then something big happened, something that changed everything. Sorry to use that catchphrase. But Apple dropped a Christmas gift for all of us on December 2022. They announced that they were going to rewrite and open source Foundation in Swift. And a year and a half later, they delivered on that promise, shipping with iOS 18 and the line releases this new version of Foundation in their platforms. And of course, they open sourced the code. And it was right around that time that Skip Tools followed. So, what is Skip Tools? Well, it's a tool chain built on top of all the open source projects, all the open source Swift projects. And it allows you to write Android apps and libraries in Swift. And this comes with no compromise to your iOS app. This means that you don't have to pay the price to carry Android around. You can still ship a perfect native app to your customers. And I also like to point out that this is not the only Swift and Android toolchain out there. There are more, but this is the one that this talk will focus on. Okay, Skip comes with two modes. One is the transpiled mode, and what it means is that it takes your Swift package and using an Xcode plugin, transpiles, which means it translates each of the lines of Swift you wrote in your code into the equivalent Kotlin, which is then compiled by the Android toolchain and shipped, delivered as an APK. Now, when using this mode, if you open up the APK, you will not see any traces of Swift in it. There will be just a regular Android app. However, not all of Swift can be transpiled to Kotlin, because some features of Swift are way too rich for Kotlin. Okay? So that's why the compiler mode exists, which takes your Swift package, compiles it natively, all features of Swift, and using an Xcode plugin, generates bridging code so you can call this code from a Kotlin code base. Now, this is all packaged up in AAR, which is the equivalent in the Java land to XC frameworks, which means you can put assets and precompiled code, and which then you can import and use from your Android application. So immediately when we saw this, we were like, OK, can we use it? Let's figure it out. So we took one of the apps we manage, which is Naturitas, an e-commerce here based in Spain. And we saw that the project is, again, heavily modularized using SPM. It's completely Swift6 compatible and relies only on Swift concurrency. There is no combine, no funny business going on. So, thank you. Thank you. This means it's a great candidate to try out the compiled mode for skip. So this is our build graph. It's a simplified build graph. And we set the mind to just share the core, right? Which is where all the business logic, data validation, parsing, networking. Wait, sorry. Damn. Okay. This is when you wish you didn't put animations. Okay. So so we set the goal of sharing this module. Okay. And moreover, we had great code coverage, so we felt like we had the moral obligation to do it. Right? And this is how project debugging, which is Catalan for freehand drawing, began. Okay, so in this section, we will now see what steps you need to do to compile your module, your Swift module for Android. Okay? The first step might seem counterintuitive, but actually build it for macOS. Why? Because there you will have the IDE holding your hand to figure out what's going on. Right? And this will also give you an opportunity to understand your dependency tree, which you might have not. It's been a while since you have taken a look at it. And you can take the step for understanding your dependencies to make sure you can maybe invert some dependencies or factor out some code. Like, we immediately saw that we were importing and using UIKit where we shouldn't have been. So we immediately paid off that tech debt and moved that code around. Another thing I would like to point out is that once you do this, once you fix some of these issues, please commit and merge into the next release. This will make sure that you don't have any long-lived branches. And this is the list of all the PRs that we were merging continuously and shipping to users in order to minimize risk. Okay? Okay, the next step is actually building for Android. Right, this is the command you have to run. I am assuming you guys can follow a getting started page on a software for a software project, so you can handle the install of this tool chain. After this is done, you will see that you have to do this on the terminal. Okay, and this is going to be a little bit daunting at first, so you can have hundreds of errors. So my suggestion is for you to pipe this output to a text file where you can easily read it. Okay, and you will see errors that are shown like this, okay? But don't fret, it's not as hard as it looks, okay? Because most of the issues fall into three big buckets. The first one is the fact that you're not using the Apple's version of Foundation, you're using the open source version, which has some changes. And we will dive into those in a second. The other is you will compile the dependencies that just don't compile on Android. And the other one is just you will have to wrap around Apple frameworks. You will be calling some Apple frameworks that are not available on Android. Okay, so let's start with the open source Foundation. As I mentioned earlier, you'll be using the open source version of Foundation, which has some little changes. One of the decisions that was made when they open sourced it is this was not a one huge all-encompassing framework, but rather separate modules. One for networking, one for essentials, and another for internationalization. So, for example, let me show you the simplest one. You have a function like this that uses URL requests and URL session to fetch some data from the network, right? This code as is won't compile for Android, but it's actually pretty simple to fix it. You just need to import Foundation networking. And you also gate this import with the hashtag ifCanImport to make sure that this code can still compile for Apple platforms. And I'm only going to show you the example for networking, but for Locale, you have to import internationalization. It's, again, not rocket science. You can figure it out. Next big bucket is the one about non-compatible dependencies. You can have dependencies like this one, where you have a package that does all the keychain access for you. But again, keychain access, that's not going to compile for Android, because you'll be using like a security framework. So what you have to do is add a condition in your package.swift that says that this target should only be built when using iOS. And the other one, big bucket of issues, is the one that you might have some code where you import core location or some other Apple-only framework. Again, here you have to kind of understand what this code is doing to make sure that, I mean, because the solution for this is actually do not compile it on Android. If you wrap the code in can import Darwin, which is a low-level module that is only available in Apple platforms, this code base will not compile for Android. But if your app is a Google Maps competitor, this is not going to fly, right? You will have to figure something out. Again, this is the part where you have to understand your dependencies. OK, by this point, your code should compile. OK, but some of the runtime behavior will not be the same as you are used to. For example, the most egregious thing is that user defaults does not persist its values, kind of defeating the purpose, right? So this is when Skip offers open source packages to fill in the gaps. We'll start by adding one called Skip Fuse. OK, back to package.swift. You have to extract all your package and target dependencies into these arrays. Imagine that they're there. What you have to do is just add a package dependencies, then this one as the target dependency, and you pipe those back into the final package declaration. Okay? After you do that, whenever you are calling user defaults, instead of using user defaults.standard, in Android, you have to do that, and it works. Okay? So it's not that big of a deal. Same thing, you can also have the same thing happens for the keychain, by the way. Okay? Once you do this, you should see on your terminal that the build completes, which is pretty cool. You will get that dopamine hit that we all like. Okay? Once you do that, my recommendation is to you to hook it up to your CI. That way, if you work in a team, your team members are not going to make any changes to the code base that will affect the Android build. Okay? And again, this is just a very light tour of how to port the package to Swift. There is this blog from the Skip guys that you should check out if you are going to do this seriously. Now, building for Android is only half of the story, because then we need to make sure that the code can be called from the Kotlin side. This is what we're going to do in this section. Okay? In order to call Swift code from Kotlin, you must first create something called JNI bindings. So WTF is JNI. Okay? JNI is a bridge that allows code that runs inside the Java virtual machine to basically communicate with native code like Swift or C or C++. Right? And this is what Skip uses to make sure you can talk to each other. The two codes can talk to each other. Okay? For this step, we are going to add yet another dependency to this package right here, and another one. And now we'll not add the target dependencies, but actually an Xcode plugin, which this was the first time I used an Xcode plugin, so I had to figure out how to do that. Okay. You also need to declare a YAML file in your module that basically tells the plugin what to do in terms of but basically it configures the plugin to make sure how and where to generate JNI bindings. With this plugin, well, this YAML declaration right here, you will have all your public types be bridged to Kotlin. Okay, there's a way to actually make that opt-in, but this is simpler, at least for the talk. Okay, and you will now hit another issue, which is that at this point you will have find two limitations. One is that not all Swift idioms are available in Kotlin, and other are just limitations of the tool itself, or at least current limitations of the tool itself. So let's start with Kotlin limitations. If you have a class like this, for example, that has an asynchronous initializer, those things are not available in Kotlin because nice things are not available in Kotlin. So you will actually gain back IDE support, which means that this error will be surfaced by Xcode now, with this actually pretty helpful error message from the Skip guys, right? So let's do what they're saying we have to do. The first thing is that we need to make sure that this method opts out of generating JNI bindings, and we do that with this annotation right here, which tells the compiler to compile it, but don't generate the JNI binding. And in order to create this class on Android, what we actually do is create a static function, and I just chose create as the keyword to that function. And that function actually piggybacks on the real initializer. This way you have two APIs, but only one code path to maintain, which is what you want anyway. Okay? And the other ones are limitation by skip itself. Currently, and this is going to be a mouthful, but skip cannot generate extension for the types defined in the Kotlin standard library. Okay, so what does it mean is that, for example, here we have an extension on string, but string is defined on Kotlin, and so it won't be able to add it for current limitations. So you have to work around it with another factory method. Again, not that big of a deal, because again, you have two APIs and one code path. Once you do that, you will be able to finally export and generate the AIRs that we mentioned earlier. The command looks something like this. Nothing to be excited about, but this is what you have to be excited about, because now we have AIRs that are ready to be called from Kotlin, right? And again, dopamine hit, right? And let's look a little bit about what just happened here. We have complex Swift code, like actors, conforming to protocols with asynchronous code. All of that is going to be bridged to Kotlin. Okay? So, without further ado, let's open Android Studio, where in this section, we will see how to call this code from Kotlin. Okay? So, welcome to Android Studio, where one of these beautiful little animals will be greeting you, depending on when you install it. Colorful. Okay, so Android Studio. It's based on, Google didn't even bother to create its own IDE. They just borrowed JetBrains. And it's a Frankenstein of moving parts based on Gradle, Java. It ships with the Android SDK and the emulators. Okay, and if you like Mac apps or nice things, you will hate every second you spend in front of this thing. Okay, but you need to, let's get the job done, because that's what we're here for, and place the ARs that we generated in the previous step somewhere where the Android Studio can find it. And here you have a bunch of options which you will have to choose with your team. You can use a custom Maven repository, use GitHub packages, even merge the two repositories and make sure there's a script that generates them. We, however, took the minimum viable product approach and just are storing the AIRs with Git LFS and calling it a day. Okay? Don't quote me on that, but this works. So don't touch it. So you need to go into your build.gradle, which is kind of like the package.swift. For Android, and you need to go into the dependencies, the declaration, and just add a snippet of code like this, where, of course, the path might vary in your case, right? After you're done with that, you need to find the little elephant that's behind the cat and the cockroach, and click on it. And after you click on it, it will actually trigger a sync of the dependencies, after which you have to go to either your main activity, which will be like the main view controller of the app, and add just one line of code to initialize both Swift and Skip's runtime. This is required for stuff like user defaults actually persisting the value. For reasons, believe me, you don't want to know. Okay? And okay, after that's done, we can finally import and use Swift code from Kotlin. For that, you need to import not only the module, but actually the symbol you want to use, and use the API that you had on Swift. Okay? At this point, your Swift code will be executed whenever you whenever you launch the Android app, which is again another big dopamine hit. But before we show some screenshots and all of that, let me show you something. That token refresher right there. Let's come and click on that. And you will go to this is a Kotlin file, right? This is a Kotlin class. What is this thing doing to do? It's actually conforming to a protocol. But where is that protocol coming from? That protocol is coming from Swift. So a magic thing just happened, that you declarated a protocol in Swift, conformed it in Kotlin, and then injected that back into Swift. So this is very, very, very cool, because it means anytime you have to integrate with OS-level APIs, you can follow this pattern. And we have used this to wrap Bluetooth stacks, to wrap push notification system. It works. It's pretty awesome. So some tips for you adventurous enough to go into this part. Something funny about Java. Anything can throw, so nothing throws. So what does that mean? It means that if your Swift code that has the throws annotation, whenever the J and I binding to that symbol will be created for the Kotlin part, it will lose the throws. So you have to remember to actually do it. If you want to be pedantic about it, you can make sure that the Swift version does not expose that throws method to Kotlin, and instead return a result type. But I was too lazy to do that. I just wrap everything into await and call it a day. Add logging, a lot of logging. Because if you can't add, because the reason why is because you can't add breakpoints to your precompiled Swift code. So in order to know what's going on, you need to actually add logging to have something to follow. Another thing you need to understand after coming from years and years and years of iOS development is that you do not expect deterministic memory behavior, because the Java's garbage collector can come and go whenever it wants. And what this means is that if you wrote a class that you thought was attached to the lifetime of a UI element on screen, well, that's not going to happen on Android, because on Android, the memory can be clear whenever the OS wants. So you have to take it back into account. And again, lots of patience when interacting with these two beasts. One is Hilt, and the other is ProGuard. And I'm not going to bother you with this, because I've had brilliant Android engineers explaining this to me over and over again, and it's one of those things that it gets stupider the more you hear about it. But don't laugh. We've all done Viper here, so okay? So what are the trade-offs here? Well, you're going to be adding at least 50 megs to your app's binary in Android. So this is also something that's to tread carefully, especially in our cases, we have clients that we develop for clients. It will also, at the very beginning, the iterate cycle will be very slow because you depend on the export phase to finish, which takes a while. So this is something that has to be fixed. And the other thing is there will be cultural friction. Like Android users will complain. And I mean, it helped a lot the fact that I could just have executive, I get paid to make executive decisions, so I just ran with it. Okay? And this is when the first version of Naturitas, that app shipped with any Swift code, June the 21st. And we've immediately found some issues with telemetry. The biggest one is that URL session has a lot of limits. Since it is, well, we saw with Firebase that like the error rate was skyrocketing for the methods that we're using it. And the reasoning is because it's based on libcurl, which is not exactly a mobile-friendly library. And another issue is that the Android developers complain a lot because the network traffic was no longer visible on Android Studio's network debugger, which is actually quite nice. Well, nice. Not visually. So what we had to do is replace it with an OK HTTP wrapper. OK HTTP is like the de facto library for networking on Android. So we use the same pattern I showed you earlier about a protocol that tells it, and we inject it. So again, not a big deal. It shipped, and now works like a charm. Some conclusions to try to convince you. All the issues you will find, and again, I haven't even discussed half of them, you can just work around them and fix them. It's just Swift code, right? The dependencies can be forked, patched, or even better, inverted. So the end result is that we are rewriting all of the Naturitas app using Swift, right? We are replacing all the subsystems that were once in Kotlin with Swift-based subsystems. This is the ones that we already did, the ones that are in progress, and the big ones are coming. The cart and checkout are, of course, the most delicate in any e-commerce app, but they will be coming. But that's not all. Skip offers also you the ability to share up until the view model layer using add observable. So we already are in other apps, not Naturitas, the other one called Medicuo. We are sharing everything up until the view model layer and using that to create natively composed UIs that are powered by the same view model that we wrote on Swift, right? This means that we as a team can now ship twice as fast Android features. And I'm sorry about that animation. I just wanted to use it for so long. I never had a chance. But there's more. Like we're in the middle of this, they announced a new feature of Skip that allows you to write Swift UI views and use those on Android, full Swift UI views with generics, view modifiers, the works. So what does this look like? This means that UI components that we had built before, like for example, this async button, can now be used on both platforms. And even view modifiers work. So for example, if you want the loading to be red, you can use that. And if you want to do something fancier, where you need to drop down to compose, you can do it and keep the same Swift UI API. This is great. And not only for buttons and something simple, like this view has asynchrony, has generics, has the works, and we are also able to share it between platforms. So around this time, we were approached by a client that had their iOS code base ready and to ship with Swift and SwiftUI, and the Android code base was in the middle. Well, it wasn't finished, and the Android developer quit. So we took their iOS code base, and a couple of weeks using Skip, we were able to port it to Android with this result. Look at that PR. Look at the language breakdown. Look at the code look at the app talking to a Bluetooth device, and yeah, uploading that to. So, for a team like ours, these, again, 10 people, this means we can get new clients without increasing team size. So, was it easy? No, it wasn't easy. It was a lot of discussion, a lot of work, a lot of late Friday with Xcode. So, was it worth it? Abso-fucking-lutely. Okay? So, how do I see this playing out in the future, right? Well, what can we do to make sure that Swift succeeds as the way to build apps? Well, first, we need to understand that there are two sides of Swift. One is the community, which is us right here, and the other one is Apple. Let's start with the big dog. Let's start with Apple. So, from Apple's point of view, they have gifted us all the pieces available to make this thing a reality, and it is a reality in some dimension. But without further investment, it risks being too little, too late. So, what steps do I suggest Apple to take to make sure Swift succeeds? Well, the first one is they need to partner with JetBrains to make sure that the integration between their IDE and SPM is at least better. And collaborate with Google to fix the problems with the binary size overhead. That's also something that I think it's something that needs to happen, because on developing markets where Android is bigger, this is a problem. And another thing is that they have to keep investing in Swift Java, which is their solution for interacting between Swift and JVM languages to make sure that succeeds. The problem with these goals is that they involve Apple working with other companies, which is something that culturally and historically has not been an easy task. So what can we do as Swift community? Well, we have a responsibility to be a beacon of excellence. We need to spread our wings and get outside our beautiful 30% taxed walled garden. Why? Because if we don't succeed, the wrong trade-offs will be forced on us. And these trade-offs will come in form of a crappy cross-platform tool chain that we don't like, right? So what else? I think we should support all the efforts that are there to make sure that Swift is available outside the Apple ecosystem. And this is as simple as making sure your open source project compiles for Android, making sure sending a $10 tip to some open source package that you like, or even paying for Skip, which is well worth its money. In that spirit, I also invite you to read, in that spirit, the Android workgroup has been created, I think, on June. And it's formed by people like you and me, well, at least more technically gifted than I am. And they meet every other Wednesday. If you're interested, you can take a look and join. Talking about taking a look, I also invite you to read the Vision for Android document that's been drafted. This is by Mark. This is one of the engineers behind Swift. I encourage you to take a look to this to make sure that, to understand if this is something you are interested or is possible for you. And I'd like to thank everyone who's been helping to make Swift on Android possible. These are in random order, generated by a computer. And I'd like to thank because without them, none of this will have been possible. And also, not only them, but also everyone behind Apple that pushed for open sourcing foundation. They were a lot. I tried to do that on the train on the way here to make a slide for them, but they were too many. So also thanks to them. And without further ado, any questions?
Thank you. Lots of questions, and again, you'll enter some of them on the Slack so that you can catch up with people. Some of them were technical, like, for instance, can you write this Kotlin code in Xcode and not have to use Android Studio?
Well, if you don't like syntax highlighting, yes. Technically, yes. If Xcode doesn't recognize the underlying code, it just treats it as a plain text file. So yeah, you can do that. What we have done, for example, for the compose code we have written to power those UIs is actually using a blank Android Studio and just using that. And as long as the inputs are simple integers and booleans, strings, stuff like that, you can have even previews like that.
So if you have C code mixed in with your Swift code, what then? If
you have C, I haven't tried that, but I think that's one of the sections in the blog post that I referred earlier. There's a section about C code specifically. I think what you will want to do, at least it will be Swift to call Swift C, and then Kotlin calls Swift. That's what I will do to make sure the JNI bridging is as cheap as possible.
So this is outside of my world, but I understand, and this question does as well, that Android is very fragmented. And so how do you deal with that? Do you have to deal with the per Android device support? What is it you're doing there?
Unfortunately, your app will be a native Android app with all intents and purpose. So that means you will have to support it as another Android app. So that means that there will be stuff that happens. And unfortunately, on Android, stuff happens.
In Android, yeah.
Stuff happens.
Thank Pierluigi, please.
Bye.